I'm just going to quickly remind you guys how to find equivalent fractions. Equivalent fractions are modified by the same scale on the top and the bottom. So we multiply the top and the bottom by the same number. So if we have a mixed number, the 2 is clearly going to stay the same. So the only thing we're modifying is the 2/3. So I really like this strategy for finding common denominators, of kind of extending out this fraction bar. And let's say here, I'm going to multiply both things by 2. 2 times 2 is 4. 3 times 2 is 6. I'm going to multiply by 3. I'm going to multiply by 4. I'm going to multiply by 5. And I could keep going. I'm going to skip. I'm going to multiply by 10. So that's 20/30. This is just an easy way to just keep going in a very organized way and get equivalent fractions across the board. So that's a way to get equivalent fractions. Let's kind of apply the same thing here. And so I'm going to multiply by 2, multiply by 3. What's 8 times 3? 8 times 8. 8 times 2 is 16. 16 plus 8 is 16, 17, 18, 19, 20, 21, 22, 23. Okay, 24. And then I can multiply by 4, and I get 20 over 32. My cool way to remember times 4 is I know that 8 times 2 is 16, and I can double 16 in my head pretty quickly. And I can do 18 times 5 and get 25 over 40, and I can keep going like that. If we were wanting to get common denominators between these two fractions, have I achieved that goal yet? The answer here is I have not. I skipped over one. So let's see, let's go back up here. If I did times 8, that would be 16 over 3 times 8 is what? Again, it's 24. So 16 over 24 and 15 over 24 have the common denominators I would need to add and subtract these two fractions. So I could go over here and I could add them. I could say I'm going to use 2 and 16 over 24 plus 15 over 24. 16 plus 15 gives me what? So 10 plus 10, I'm going to do 10 plus 10 and get 20. And then 6 plus 5 is easy to do in our heads and get 11. And then 20 plus 11 is 31. So I get 2 and 31 over 24. Uh-oh, I have a problem with that. 31 divided by 24. So this only goes in one time. So to get from 24 to 31, I can get 6. 1 more than 6 is 7, right? So let's again, 24 plus 7. Yeah, that's right. So this part is equal to 2 plus 1 and 7/24. So the entire answer there would be 3 and 7/24 if I were indeed adding those together. But you have to find that common denominator to add those together. So that's just my quick little way of finding equivalent fractions. And next we'll kind of talk about a way to simplify fractions. Okay, let's say we have the two fractions, the two proper fractions, 20 over 32 and 15 over 60. They are proper fractions, but they're not simplified. So what we're going to need to do is list out their factors. So the factors of 20 are 1 and 20, 2 and 10. What else? 3 doesn't go into it. 4 and 5. So right after 4, I get back to the 5. So apparently this is the list of all of its factors. So 32. So obviously it's 1 and 32, 2 and 16. 3 doesn't go into it. And we'll talk about how I know that in the next video. So let's skip over to 4. 4 and 8. 5 doesn't go into it. 6 doesn't go into it. 7 doesn't go into it. And then we're back to our 8. So we know we're finished with all of our factors. So what's the biggest one for the G, C, F? The biggest one is 4. So that means I can simplify both of these by 4. And I get 20 divided by 4 is 5. And 32 divided by 4 is 8. So this is, in simplest form, 5/8. Now, another way that we could have done that, the longer way without listing out all the factors, is we know they're both even. So I know I can divide by 2 and get 10/16. We know both of those are even also, so we can divide by 2 again and end up at 5/8. But if I could divide by 2 and then divide by 2, 2 times 2 is 4. So I could have divided by 4 to begin with. So again, we do know that one ends in a 5 and one ends in at 0. So we can maybe assume that the greatest common factor is going to be 5. So let's just start out with that instead of listing the factors. 5 and 0, we know that they can both be divided by 5. Divide by 5. 15 divided by 5 is 3. 60 divided by 5, for those of you that don't want to do it in your head, 60 divided by 5. So what I do is I do 6 divided by 5 is 1, right? And then, so that leaves me 1 left over. And I know that 5 can go into 10 twice. But let's do it the long way also. 5 goes into 6 once. Here was my 1 left over, which is actually a group of 10. And 5 goes into 10 twice. But that's how I did the division in my head. Is I made a group of 50 and a group of 10, and I figured out how many times 5 goes into 50. It goes in there 5 times. How many times does 5 go into, it goes in there 1 time, right, or 10 times, and then how many times does 5 go into 10? It goes in there twice, and 10 plus 2 is 12. So I know I bumbled that description a little bit. So it simplifies to be 3/12. So can 12 be divided by 3? It can. So this isn't in simplest terms yet. So I'm going to divide by 3 again. And divide by 3 again. 3 divided by 3 is 1. And 12 divided by 3 is 4. So this is 1/4. So that means that over here, instead of dividing by 5 and then dividing by 3, I could have divided by 15 at the very beginning. Is that, you guys following along with that? And I could have listed out the factors to get to that. Is one method better than another? No. It's whichever method that you understand. This one might be faster and take you to the final simplified version more quickly. But if you want to just go with the fact that these are a 0 and a 5, we know they're divisible by 5. And then look here, the easiest thing to do in the second step is to kind of see if the first thing you can think is, can the numerator go into the denominator? And if it can, that means they can both be divided by the numerator. And if we ended up like here, where both of them were even, we know again that they can be divided by 2. So I hope that kind of clarifies something about simplifying fractions, finding the greatest common factor, or just by using some of the divisibility rules that we'll talk about in a few minutes, or in a